So my name is Stefan Barot from Balrampur Chini Mills. I'm a president chemical division there, and it's good that we have the time over there. So first, quickly, what are we doing as Balrampur Chini Mills, and what is PLA? So we are the second biggest sugar producer in India, the biggest ethanol producer, and we decided to go into PLA, polylactic acid. Our plant will come up in UP, which is the first in the world, directly from sugarcane to PLA in 2026. Now, what is PLA? PLA is a linear biopolymer, which is bio-based and compostable. So we have a material which basically uses biocarbon in its chain, and it is compostable in industrial compostability. Why is this important? Now I need to get to my notes, otherwise I mess it up. Thank you. So I think we all realize that too many instruments with me. Global warming is real. We see it in the news, we can feel it ourselves. And we need to reduce greenhouse gas emissions in one way or the other. And the question is, what has this to do with packaging, and what has it to do in the end with PLA and biopolymers? And the answer is a lot, or everything. We have about 26% of global greenhouse gas emissions coming from food production, and 6% of these 26 are from food that is never consumed. 1% of this 26 is from packaging, and out of this we can conclude, if we can extend the shelf life of a product with packaging, we need to pack, because the damage to the environment is much less than if we let the food rot. By the way, 4% of the 6 are because the food doesn't reach the consumer. 2 are after that. The question then, of course, is, does this not include or increase plastic pollution? And the answer is yes, it increases plastic pollution if we don't manage the plastic waste properly. And I think that is the biggest problem we have. We have a linear system now, which is basically just wasting materials, and we need to construct circularity for the packaging. So to build this circularity, we can go into, and this is the next slide, if it allows. We can either go into composting, chemical or mechanical recycling, and the technologies to do that actually exist. We need to deploy them. And how we do that, we can later on discuss a bit in more detail. And the question, of course, is how can biopolymers help to do that? Well, in the past, any product needed to fulfill 2 requirements, and still needs to fulfill the requirement. First of all, it needs to be functional. It needs to serve its purpose. The second is it needs to be producible on an existing equipment. If you can't do that, it won't work. And now comes a new requirement. We need to build in circularity. And if we fix one of these requirements, it will have automatically an impact on the others. And that's what we need to highlight a bit. So PLA is a compostable polymer, and compostable polymers offer new functional advantages. For example, if you have a heavily food-contaminated product, you can send it together with the biomass waste to composting. I think the challenge is overall holistic thinking. How can we ensure that we don't push the problem from one part in the value chain to the next part in the value chain? For example, we can produce a product or packaging that degrades within 3 months in the environment. The challenge will be we will need to move the whole supply chain to refrigerated products, and that is probably self-defeating. We have other applications which multi-layer packaging, which we can make compostable, or mulch film, or plastics which are left in the environment. So, in summary, bio-PLA and biopolymers offer all circular possibilities. So here are a couple of the applications what we can do. But they need holistic thinking. And we are happy to work with anybody who is willing to work with us through the supply chain to get the best possible solution. We have a booth out there. I'm happy if you come to our booth and basically discuss with us what can be done.